All right. Hi, everyone. Today we are having with us an absolute legend who needs no introduction, but still I would like to introduce him. Today we are having with us Professor Gilbert Strang. He is an American mathematician known for his contribution in the field of finite element theory, calculus of variation, wavelet analysis, and our most special topic, linear algebra. He has made many contributions to the field of mathematics, including publishing mathematics textbooks. And yes, we have one good news also. His two textbooks of mathematics are now available in India. I would like to recommend them. First one is Introduction to Linear Algebra. Second is Linear Algebra and Learning from Data. If you are someone who wants to learn everything from scratch and want to visualize every single concept of linear algebra, then your first book can be the best book for you. And if you are someone who wants to see how we can merge linear algebra with machine learning, then second book can be a best book for you. So make sure you check out this particular page which I'm going to put in this video while I edit, and you can purchase these two books if you want. Okay, and again back to the introduction. Wilbur Strang was the professor of mathematics at MIT. He only popularized the designation of fundamental theorem of linear algebra, which we all study now when we do our course. MIT 18.06 course of linear algebra, which is freely available on YouTube, has introduced millions of students across the world to linear algebra. So now I will want to welcome you, Professor, on this podcast. And this podcast is going to be very special to all Indians, including me. Thank you for taking out your time and thank you for coming.
Well, it's my big pleasure to be part of the podcast and speak to the. I know that because I get a lot of nice messages from India. I know that the videos that MIT created,
Yes, yes.
the open courseware, are known in India, and you should know that I'm still. Adding a few more as I think can be useful. So there's the series of lectures stays the same. That's the original lectures to my MIT class. But then in the open courseware is a section called 2020 Vision for Linear Algebra. And that
Okay.
was my chance to put in some new ideas
Yes, yes.
about teaching and learning linear algebra.
Yes,
So, and that includes, it goes back to the four fundamental subspaces. Uh,
yes.
and so I'm happy to talk about that subject too. Yeah, good.
Yes, yes.
So there are two things that I want to tell everybody about, and that is the four fundamental subspaces and the new idea there, because the new idea is useful in data science, where matrices, generally the matrix in data science is not square, so
Yes, yes.
it doesn't have a normal inverse, but
Yes.
still it's the data, and
Yes,
that's what
yes.
we work with. Yeah. And the other thing I want to mention and shall start is the two books that you were kind enough to mention. So within India, the so those are printed in India. They're sold at prices appropriate
Yes,
and
yes.
by Wellesley Publishers. So
Yes, yes.
Wellesley is the little town I live in near
Yes, yes.
Boston. So I chose for the name of my activity Wellesley Cambridge Press because Wellesley's where I live and Cambridge is where I work. That's where MIT is and Harvard too, but we pay attention here to MIT. So that's Wellesley Cambridge Press for American contacts and books, and Wellesley Publishers for the contact in Mumbai, actually.
Yes,
Uh,
yes,
so, yeah, so it's, um, I think, I guess my hope is that that IITs and other major education uh,
hmm,
uh, will will see the value of these two books
yes,
in
yes, sir.
published published in
Definitely,
India.
sir.
Anyway, that's so the four fundamental subspaces, that's the mathematics for part of the mathematics for today. Yeah,
Yes,
good.
yes. So, sir, definitely, I am going to also recommend to my all audience that you can definitely check out both of these books. You can definitely check out link given in the description. And also, I want to admit one particular fact that linear algebra before knowing Gilbert Strang playlist was different thing, and after seeing your playlist is completely different world. Professor, can you please tell us the story behind when did you realize that all four fundamental subspaces should be taught together? Was it while teaching a class or while writing a book?
It certainly is something that I introduced that idea of the four fundamental subspaces. Of course, people already know these spaces, the column space of a matrix. That's
Yes,
the key example, the column space of a matrix. So that, what is that? All combinations of the column vectors. So the
yes,
matrix has n column vectors, and all their combinations produce a vector space. So a
yes,
space is, when I use the word space, that's saying that all combinations are included.
yes,
Like geometrically, it's like having a plane in three-dimensional space, a plane
yes,
that goes through zero.
yes,
So that would be a subspace of three-dimensional space. And the great thing about linear algebra is that you go up to nine-dimensional subspaces of a 12-dimensional space. That's it's not easy to visualize. It's hard to imagine a 12-dimensional space. So what we really imagine is two or three-dimensional spaces, but linear algebra allows us to take any number, any dimension, and then a subspace is like a plane within three-dimensional space, or a line within two-dimensional space, a line that goes through the origin, or a plane that goes through the origin, because the subspace must include the zero vector and must include every multiple. So it's a square full of vectors would not be a subspace. It has to go out to infinity. Anyway,
mhm,
that's a key idea, and somehow we get better at visualizing a three-dimensional subspace of five-dimensional space. Well, when I say better at visualizing, I don't know what I mean, because it's not easy to visualize, but somehow you have the idea of how it works. Yeah.
yes, yes, yes. So I want to tell you, sir, when I used to study linear algebra, I used to just solve questions. But
Yeah.
after seeing your lectures, I started visualizing what is column space and how that visualization helped me to learn concepts actually in depth. Before that, I used to just solve row reduction method, determinant. I was not
Right.
knowing what I'm actually doing. So
Yeah.
very, very
Yeah.
thankful for those lecture.
Well, I'm glad. Yeah. It, I also learned linear algebra in an old-fashioned, well, very theoretical way. But it's linear algebra is a beautiful combination of mathematics and actual computing, because we need a way to find the eigenvalues of a matrix. Those are important numbers, and now have become very important, the singular values of a matrix. Eigenvalues apply when the matrix is square. Singular values apply to every matrix.
Yes.
And they're keys to computing. And singular values are they take a little more thinking, a little not. They're not quite so eigenvectors are simple. Are simple to visualize. An eigenvector is a vector when you multiply by the matrix, the result is in the same direction as the input. The
Yes.
output is in the same direction as the input. So we have eigenvectors. Singular vectors are another step, and I won't take that unless you want me to. Yeah.
Yes, 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 sir. That's really beautiful, Professor. I know, sir, many beginners will also be watching this podcast. So I would like to ask you, how do you think a beginner should start studying linear algebra? And also, what are the common mistakes which you see students usually do? And why it is so important people say that you should learn linear algebra before going to machine learning?
Well, let me answer or speak about machine learning and that question. Uh, so, so machine learning, uh, the great idea in machine learning is to have uh, to have not just one matrix, but a sequence of matrices. So and also machine learning has that critical nonlinear function, a simple nonlinear function, but it makes the whole it makes the big difference. It makes the success of the idea. So that simple function is piecewise linear. It's zero, and then it's x. So the function that has a graph that's flat, zero for negative x, and 45-degree straight line uh, slope for positive x. So piecewise linear, two pieces, and it just is turning out that leads to piecewise linear functions, and that they are much more flexible than linear functions. Linear functions are quite limited. Piecewise linear functions, we don't have those limitations. They're not linear. They're nonlinear, but they're not complicated. They're not curved. So they've turned out to be a valuable idea in practical computing and in deep learning. Yeah, yeah. I
Also,
think
sir,
there's more to learn about piecewise linear functions, but um, that subject is just developing quickly. This is not a piecewise linear day. This is for linear algebra and the four fundamental subspaces. So, shall I say something about the four
yes, sir. Yes, sir.
subspaces?
Yes, sir.
Okay. First of all, what are they? So I have a matrix, a square, a rectangular usually, say m rows and n columns.
Yes.
And how do we define the column space of that matrix? So
All
we have
columns.
any rectangular matrix. It has n columns. The combinations of those columns, the linear combinations of those columns, give us the column space.
Yes.
So suppose we have a matrix with 2 rows and 3 columns. So it has 3 columns, and those columns are in two-dimensional space because there are only two rows. The columns only have two numbers. So I have three vectors in the plane in two-dimensional space. And I take all their combinations, and that gives me the column space. Now, usually with those numbers, the column space is probably the whole space. But let's think of another example. Suppose we're in 10-dimensional space. So we have the columns have 10 vectors. Sorry, yeah, the columns
components.
have 10 components. So 10 rows in our matrix. Every column, there are eight columns now. And so say again, 10
Eight.
rows, 8 columns.
Yes.
So eigenvalues don't come into that picture. Eigenvalues are for square matrices, and but the column space is truly important. So what's the column space?
Combination, linear
Everybody's
combination.
got their mind on 8 columns, and each of those columns has 10 components, so it's a vector in 10 dimensions. So what's the space? That word space says take all linear combinations. So I have those 8 vectors, and I take all their combinations, and that fills out a flat, what can I call it? Can I call it a plane? It's when I say plane, you visualize a two-dimensional subspace in 3 dimensions. That's where we live. But in linear algebra, that word space, we can be in 10-dimensional space and have 8 independent vectors, and their combinations fill out. Should I call it a plane when it's flat, somehow flat, whatever that may mean in 10 dimensions? But it's your instinct is sort of right, even though you can't picture it too well. Anyway, that space is the column space of the matrix. So it's all combinations of the column. And then what is the row space of the matrix? Well, you're going to guess correctly. All combinations of the rows.
Yes.
And so the matrix then, every matrix has a row space, combinations of the rows. Those are vectors in n-dimensional space. And column space, which are combinations of the columns, and those are vectors in m-dimensional space. And now the main point. If I start with a vector in the row space and I multiply by the matrix, so x is in the row space, multiply by a, I get a times x, and that's a vector in the column space. When I multiply a matrix by a vector, I get a combination of the columns, and combinations of the columns get
column space.
What they fill the column space. So the matrix takes us from the row space to the column space. By multiply by the matrix, take any vector in the row space with m components, with n components, multiply it by the matrix, and I have a vector with m components in the column space. Okay, an example would be better. If I had a blackboard, I would do a. Well, let me ask everybody a question. Suppose the matrix is a vector is all ones. Suppose I have a matrix with we're taking with 10 ones in every column, and I have 8 columns. Okay. Yeah. Well, what's the column space for the matrix of all one?
Line,
And
one
what's the
line,
dimension of that space?
one, one.
So just think of all combinations. Well, the combinations are going to be all in the same direction. So I
Yes,
think in that case, we have, for a
one.
matrix of all ones, the dimension of the row space and the dimension of the column space are both one,
Yes,
just the number one, because
yes, yes,
all the vectors that we have are vectors of constants. Three,
yes,
three,
yes,
three, three, three.
yes,
Fine.
yes.
Okay, so those are two of the four fundamental subspaces: the row space created from the rows, the column space created from the columns, and the other two subspaces are the null spaces. They're when you have all the vectors that all the solutions to ax equals 0. Now, the only solution might be x equals 0. In that case, the null space is just 1 point, the 0 vector. But if I have a wide matrix and many, many columns, then there will be other combinations to give me the 0 vector. So anyway, then those are those solutions to ax equals 0, or x is in the null space. So that's
Mhm.
3, and the fourth is the null space of A transpose. Flip the rows and columns and solve A transpose x equals 0. Then that gives you the other null space, the null
Yes,
space of A transpose. That's enough
yes,
for talking. That's
yes, yes.
if I had a blackboard, it would be very clear. Good. Yeah, let me talk about question, which is some common mistakes maybe, and why is linear algebra so important for machine learning? Well, let me answer that question again. So linear machine learning involves how to fit data by some nice surface, how to by some nice function, you could say. If I have 1,000 data points because I've done 1,000 measurements, what kind of a fit should I give for those 1,000 points? Well, the answer in the old days was fit a polynomial through those points. But that polynomial is very unstable. To go through 1,000 points, it has to oscillate very much, and it's not stable. Much better to do piecewise linear. That's stable. And that's the heart of machine learning. So it still has a lot of the advantages of linear algebra, still uses matrices, but it uses more than one matrix. So it has more than one plane. It has many, many planes that fit together in a piecewise linear function. That everybody has to try to imagine a piecewise linear function. So it's it's got plane boundaries between the pieces. So it's not just any old shaped piece. It has plane boundaries. The planes cut up the whole space into many pieces, and our functions are linear in each piece, and they're continuous at the meeting point. It's a continuous piecewise linear function. That's a great class of functions, continuous and piecewise linear, and they come from using a chain of matrices. and the whole process of deep learning. So there, that's the geometry, is to visualize uh, like a perhaps like a Chinese roof or Japanese roof. It has flat pieces that fit together along the edge. Yeah, good,
Yes, yes.
good.
Professor, I would now like to share a few questions with you, which were asked last year in GATE Data Science and AI exam. Actually, GATE is an entrance exam to do masters in India. And out of this exam, I am sharing with you linear algebra specific questions. Out of all these questions, could you please tell us which one you find the most interesting and why?
Yeah, your message to me said, I would like to share a few questions that were asked last year in the GATE data science exam. So GATE is the key exam in India. It's very interesting to see these questions.
Yes,
Uh,
yes.
I think they're many of them are quite good questions.
Out of this,
Okay,
which was your favorite?
shall I pick one question?
Yes, yes.
Uh, well, here's one. Suppose A is a matrix, square matrix, and it has the property, I better put glasses on to get it right. A cube equal A. A cube equal A. So, first question, is A sure to be invertible? If A cubed equals A, is A sure to be invertible? Answer, no, because the zero matrix has 0 cube equals 0. Is the determinant 0? No, because the matrix might be the identity matrix. You see how I answer it by just thinking of an example.
Yes, yes.
So, so the identity matrix would have A cubed equal A, and its determinant is 1. So the sum of the diagonal elements of A is 1. No, certainly not, because A could be the identity,
Yes,
where the
yes.
sum is n, or A could be the zero matrix. Now here, the fourth possibility to ask, A and A squared have the same rank. Now, is that true? Ha! Again, let me ask the question. If A cubed equals A, does that tell us that certainly tells us that A and A cube have the same rank. Does A squared have that same rank? Yes, it does. Because A squared, the rank of A squared might equal the rank of A or smaller. It couldn't be larger. The rank can't grow when you multiply. And so A squared, the rank of A squared is not bigger than the rank of A. But then if we multiply again to get A cubed, that's the same as our original A. So that's telling us that the rank can't go down because we're getting back to the same matrix. So A and A squared do have the same rank. The solution to the question, if A cube equal A, then A and A squared have the same rank. Okay, and many of the audience can think about similar questions about the rank of a matrix. The rank of a matrix is very important. Yeah, yeah.
Okay. Professor, we all in India truly love you. Whenever we teach linear algebra here, everyone gives your reference. You have created such a deeper impact through your teaching. Can you please share your journey, like what it takes for a teacher to create this kind of impact? What should we keep in mind when we teach anything? Can you please share?
First of all, the students are your friends. You're helping them and helping yourself and learning yourself, and at the same time they learn. So there's a close relation between the teacher and the student. And it's a very nice relationship because the teacher doesn't know everything and the students don't know everything. So they're both struggling to learn. Maybe the teacher knows a few more things that he wants the students to learn. And examples are the way to learn. Examples are certainly the way to learn. So I described the four fundamental subspaces, but I didn't do an example. And that's the only way to teach it. So I recommend you take a matrix A. Well, start with a matrix A of all ones. Say a 3x4 matrix, 3 rows, 4 columns, 12, 1. What are the 4 subspaces for that matrix? What's the column space? Let me ask everybody listening. So I have a matrix, three rows, 4 columns. So each column is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1.
One line.
So what is the column space of that matrix?
Line.
Well, you might say it's the vector 1, 1, 1, but wrong. Column, that word space tells you take linear combinations. So we can take combinations of 1, 1, 1 and 1, 1, 1. And what does that give us? That gives us all vectors of the form AAA, 6, 6, 6, 8.5, 8.5, 8.5. So our space is one-dimensional. The column space is one-dimensional, but it's not just the point 1, 1, 1. It's the whole line there. Yeah. So it's good to think about the simplest examples and the geometry behind it. Yeah, lots to do. Oh, you students are lucky. You've got so many things to learn, and there's such nice results. Yeah, so to see the mathematics, you really need to see the slides at least, or the blackboard. So please have a look at the OpenCourseWare, ocw.mit.edu, and you'll see if you go to the linear algebra course number is 18.06. So if you go to ocw.mit.edu/1806, or if you'll find the lectures, which I did at the beginning of OpenCourseWare. That's
Yes.
25 years ago. Oh, it was nice to be young. But now but also I hope you will look under the heading a 2020 vision of linear algebra for some new ideas and new thoughts about the 4 fundamental subspaces, about singular values, singular vectors, all kinds of good things are in there. Yeah. Okay. That's
Yes.
linear algebra for today. Thank you.
Yes, sir.
And
Thank you,
good
sir.
luck to everybody. And
Thank you,
thank
sir.
you for so many friends in India. It's
Thank you,
a
sir.
great pleasure. Good.
Yes, sir.
Thank you so much.
Thank you, sir. Thank you,
Good.
sir. Thank you, sir.
Bye.
Bye, sir. Okay. In the last, I would again like to thank Professor Gilbert Strang. You are absolute legend, and we all Indians truly love you. Whatever time you have given, it was very precious for me. And today is the day which I am going to celebrate for the rest of my life. So I'm very thankful to you, Professor Gilbert Strang. And it was a very big honor for sharing few minutes with you. So अभी हमने ये वीडियो कंप्लीट किया है, और मैं सच में बता रहा हूँ कि इससे ज़्यादा अमेजिंग फीलिंग मुझे पहले एक बार आई थी, जब मैंने गेट एग्ज़ाम क्रैक किया था और मैं आईआईटी बॉम्बे में एमटेक करने गया था। उसके बाद आज आई है, और ये बहुत ही अमेजिंग फीलिंग है। कभी सोचा नहीं था कि मैं जिनकी प्लेलिस्ट देखता हूँ, कभी उनसे भी इंटरेक्ट कर पाऊंगा और उनके साथ लीनियर अलजेब्रा का कुछ डिस्कशन कर पाऊंगा। सो मेरे पास आज ज़्यादा कुछ वर्ड्स नहीं है। पहली बार मैं बहुत नर्वस फील कर रहा हूँ, और ऐसा कभी सोचा भी नहीं था कि ऐसा कुछ करना है हमें या फिर ऐसा कुछ कर सकते हैं। मैं बहुत ज़्यादा थैंकफुल रहूंगा गिलबर्ट फ्रैंक का अपनी लाइफ टाइम तक, कि उन्होंने हमें एक टाइम दिया और उन्होंने एक्चुअली गेट एग्जाम का एक क्वेश्चन भी हमारे साथ डिस्कस किया, राइट। तो एक बहुत ही स्पेशल फीलिंग है ये। और अगर आप गेट डेटा साइंस एआई के एस्पिरेंट हो, अगर आप गेट डेटा साइंस एआई की तैयारी करना चाहते हैं, अगर आप मेरे साथ तैयारी करना चाहते हैं, तो आप करने के बारे में सोच सकते हैं। उसमें लीनियर अलजेब्रा, प्रोबेबिलिटी स्टैटिस्टिक्स, मशीन लर्निंग, एआई मैं ही डील करूंगा, और बाकी के सब्जेक्ट्स हमारे दूसरे अच्छे फैकल्टीज डील करेंगे। अगर आप गेट डेटा साइंस एआई क्रैक करना चाहते हो, आप डेफिनेटली हमारे कोर्स के साथ प्रिपेयर करने के बारे में सोच सकते हैं। कोर्स का लिंक डिस्क्रिप्शन में होगा। ओके। और आपकी अमेजिंग प्रिपरेशन में कराऊंगा पूरे 1 साल तक, और आपका गेट डीए मेक श्योर करूंगा कि आपका क्रैक हो पाए। ओके। सो थैंक यू। अगर आपने ये वीडियो देखा है, आप ये वीडियो हर जगह शेयर कर सकते हैं, क्योंकि बहुत ही स्पेशल फीलिंग है कि पहली बार गेट कम्युनिटी में ऐसा कुछ हुआ है कि प्रोफेसर गिलबर्ट स्ट्रैंग ने आके खुद हमारा गेट एग्जाम का कोई क्वेश्चन सॉल्व किया है। तो एक लेजेंड ने हमारे गेट एग्जाम को पहचाना है आज, और उसके क्वेश्चन सॉल्व किए हैं हमारे साथ। तो एक काफी अच्छी फीलिंग है, और उनका सॉल्व करने का तरीका भी काफी अलग था। ये एक अचीवमेंट है मेरे लाइफ का, जो मैं लाइफ टाइम तक चेरिश करूंगा। ओके। थैंक यू। अगर आपने वीडियो देखा है, आई एम वेरी वेरी थैंकफुल टू ईच एंड एवरी पर्सन। आपके किसी भी वे में आपने मुझे अभी तक हेल्प किया है, उसी वजह से आज ये पॉसिबल हो पाया। थैंक यू।
जान जाए जाए पर खाली कभी ना बांध जाए, वचन जाए ना कभी, चाहे चले या प्राण जाए, घमंड जाए ना जिसके हृदय में हनुमान जाए।